All right, hello Enrichment. So this is what we did in class February 8th, which is Monday. So in your Google Classroom under week 24, we did this in-class practice word problems. So basically what we did is we practiced the first 3 slides of word problems. That was it because I realized slides 4 and 5 would maybe be a little bit too much. You maybe haven't done it yet, and I didn't want to blow your brains. So I didn't want you guys to freak out. And then slide number 6 is if you can solve the equation for 1 through 3, slides 1 through 3, you can get some extra credit points, but you have to show a picture showing the work you did. You can't just give me an answer. So when you do a word problem, the first thing you want to do is just take what we know, what they gave us in the equation. So we're going to type that on the side here. So let's talk about Taylor. Taylor bought ice cream and apples at Jewel's, and she paid $24.43. She paid $5.15 for ice cream and bought 4 bags of apples that each cost the same amount. We're going to write an equation that represents how much each bag of apples cost. Okay, so we're trying to figure out right here, it tells us that we are trying to figure out how much each bag of apples cost. Okay, so that's going to be our variable, right? And since we're talking about cost, we'll make that C. So C equals cost of bag of apples. Okay. Now, the next thing that we know, right, that we know for sure 100% is that she paid a total. So we know that she paid a total of $24.43. So I'm going to write that in here. Paid a total of $24.43. All right, the next thing that we know from this word problem is that she paid $5.15 for ice cream. She paid $5.15. So ice cream costed her $5.15. And then we also know that, she bought 4 bags of apples, right? We also know that she bought 4 bags of apples. So let's write that out. All right, so when we do a wordy setup here, right, you always want to put the total on one side by itself of the equal sign. It can be the left side, it can be the right side. I'm going to switch up between the two. So I'm going to start with saying my total. So we know that she paid a total, and that's what we have written in green. We know that's going to equal, she bought ice cream and apples at Jewel. So we know the ice cream cost. And when you buy something together, you're adding those 2 items up. You're not subtracting, you're not multiplying, you're not dividing. So we add the 2 costs together. So we have ice cream costs, and then we have bags of apples. We did in pink. Now, we know our total is $24.43. And, before I type any further, we know our ice cream costs $5.15. Well, if our total is about money, then everything we have needs to have some type of cost, right? Well, the only thing that doesn't have a cost here is these 4 bags of apples. But see how our variable is the cost of a bag of apples? So we're going to add our variable onto those apples. So what I mean by that is ice cream cost us $5.15 plus we bought 4 bags of apples, each at a cost we don't know. So that's why it gets that variable C. Okay. Looking at number 2 here, Jocelyn wants to ride her bike 17 miles this week. She's already ridden 5 miles and she will ride for 3 more days. Write an equation that represents the number of miles she rode each day to meet her goal. So stuff we know. Well, we know she wants to ride 17 miles, right? We got that information from right here. She wants to ride 17 miles. We also know that she's already ridden 5 miles. And Miss Rawolf and you, we both got this information from right here. let's see. We also know that she's going to ride for 3 more days. Let's do that not in green. So she will ride for 3 more days. Okay. Now, so far we have all this information, but we don't have a variable. We need that variable that's going to help us with solving. Well, in my statement here, we're told to write an equation representing the numbers of miles she rode each day. Okay, so that's where a variable comes from, right? So I'm going to put M for miles, number of miles each day. Now, again, if I look at this yellow and this green, these talk about miles, right? And our miles, if both of these are talking about miles, but this blue guy is talking about 3 more days, this is going to probably be where we attach our variable because it doesn't talk about miles, and we're trying to figure out M for miles, number of miles each day. These are the days they're referencing, these blue days. So our total in this case is what she wants to ride, right? That's 17 miles. And I'm going to put it on the right side of the equation this time. But the 2 things that are going to make up what she wants to ride are what she's already ridden, which is those 5 miles, plus the ride for 3 more days. Those are the things that will make up the 17 miles that she wants to ride. So if I write this in the equation, we get 5 plus 3 more days, but we don't know how many miles she's riding each of those 3 days, hence why we add the M there. Equals the total 17. She wants to ride 17 miles. All right. Looking at number 3 here. So Alexandra needs to get her computer fixed. She took it to a repair store. The technician at the store worked on the computer for 5.25 hours and charged her $58 for parts. The total was $661.75. Write an equation that can be used to determine the cost of the labor per hour. Well, we know that he worked on the computer. All right, let's make that shorter. Worked for 5.25 hours on the computer, right? We get this information from this phrase here. We just abbreviated it, made it a little shorter, a little bit easier to read. We also know that he charged $58 for parts, right? Charged $58 for parts. And the final thing that we know from this word problem is the total was $661.75. Now we need to have a variable, right? We talk about everything we know. What do we not know? Well, we don't know from our statement here. Write an equation that can be used to determine the cost of labor per hour. So that's what we don't know. We don't know another cost again. So we don't know the cost of labor per hour. So I'm going to have C stand for cost. Now, cost of labor per hour. Of the blue, orange, and red, the only one that talks about hours, and I forgot to write it, was the red, right? So that's where we're probably going to attach our C, right? Because we don't know the cost of how much he worked when he worked those 5.25 hours. But our total talks about money, so we need to be able to get this guy to be some type of monies. So if we write this out, it's going to be total equals what she was charged for parts plus worked per hours. Okay. And when we put this with the numbers, we get 661.75 equals charge for parts plus the 5.25 hours times however much each hour cost. Okay, so again, if you want extra credit, solve those 3 equations. If you don't want extra credit, turn in what you got right now. All right, everyone, have a good day.